We're going to find the length of the curve y equals x to the fourth over 8 plus 1 over 4x squared, and x is from 1 to 2. Normally we might graph it, but in this case we are not going to, as long as the function does not have a point of discontinuity on the interval that we're given. And the only point of discontinuity in here is when x is 0. So we're going to use the formula that length is the integral from a to b, the square root of 1 plus the derivative squared dx. I'm going to rewrite the function. F of x is 1/8 x to the fourth and 1/4 x to the negative 2. I like to write it with power form. Now I'm going to do the derivative. F prime of x is 4/8 x cubed plus negative 2 times 4, negative 2/4 x to the subtracting 1, negative 3. So I can rewrite the derivative as 1/2 x cubed minus 1/2 x to the negative 3. I'm going to rewrite the derivative as one fraction. So it's x cubed over 2 minus 1 over 2x to the third. Writing it with a common denominator, which would be 2x cubed, which will put an x cubed and an x cubed, I get that the derivative is x to the sixth minus 1 over 2x cubed. Now I've got to do the derivative squared, which is x to the sixth minus 1 squared over the square of 2x cubed is 4x to the sixth. So now I'm going to rewrite the derivative of f squared. I FOIL the numerator, and it's x to the 12th minus 2x to the 6th plus 1 over 4x to the 6th. Miraculously, we add 1, but we add it as 4x to the 6th over 4x to the 6th. And sure enough, what we wind up getting is x to the 12th plus, instead of negative, 2x to the 6th plus 1 over 4x to the 6th. Now my last step before I do the integral is I have to take the square root of all this. So the square root of 1 plus the derivative squared is the square root of, I am going to factor this numerator, so this becomes x to the 6th plus 1 squared over 2x cubed squared, and the square root releases what was squared, and I get that that is x to the 6th plus 1 over 2x cubed. This is what's going to be the term in the integral. We're now ready to do the integral. So it's the integral from 1 to 2, and we put in what we got here, which is x to the 6th plus 1 over 2x cubed dx. But this is one where we separate the numerator over the denominator. So it's the integral from 1 to 2, x to the 6th over 2x cubed plus 1 over 2x cubed dx. But I like to write everything with the power, so I need x to a power. So this becomes the integral from 1 to 2, 1/2 x cubed, because x6 over x3 is x cubed, and 1/2 x to the negative 3 dx. Now I'm ready to integrate. So the antiderivative is 1/2 x to the fourth over 4 plus 1/2 x to the negative 3 plus 1 is negative 2 divided by negative 2 from 1 to 2. I'll write this now as x to the fourth over 8 minus 1 over 4x squared from 1 to 2. And I'm now ready to do the computation. Substituting 2, I get 2 to the 4th, 16/8 minus 1 over 4 times 4 is 1/16. And now substituting 1, I get 1/8 minus 1/4. Working this, we get this is 2 minus a 16th minus 1/8 minus a 4th is negative 1/8. So it's 32 minus 1, 31/16 minus a minus plus 1/8, and 1/8 is 2/16. So that length is 33/16.